Namaste. My name is Anne-Marie Walters, and today I'm going to be talking to you about improving the resilience of industrial infrastructure and city assets. I would normally be with you in India for the ARC event, but like almost everyone I know, I've been working remotely and doing my job from my home office, which is actually my dining room table. I am totally reliant on my computer and my network. Real-time tools for collaboration have become essential, and having access to up-to-date, reliable information across my organisation is critical to be effective. This is what Digital Twins provides. As I've been speaking, I've been playing a video we put together showcasing real-life examples of digital twins in cities. This video shows the sort of data that city workers have access to from their home offices or from their desks for day-to-day planning and doing things like monitoring floods, monitoring roadworks, all in real time. In fact, all manner of use cases that occur in the day-to-day running of a city. The same type of easy access to up-to-date real-time information, be it 2D, 3D or visual or via a GIS, is needed across all industries, utilities and all types of infrastructure, as well as in cities. Today, my presentation will cover some more examples of digital twins in use today and hopefully give you a sense of what is going on all across the world. First, though, a bit about Bentley. We are a software company whose mission it is to provide innovative software solutions for enterprises and professionals who design, build and operate the world's infrastructure. We cover a whole manner of infrastructures: cities, oil and gas facilities, power generation, roads and highways, all of that sort of thing. Our business is split into 4 distinct areas. We cover both the capital project side of the business with our project delivery and design integration business units. Our design integration business unit has a whole raft of engineering, design and analysis tools that are actually used both in project delivery and operations. We also have a division focused specifically on operations and maintenance under our asset and network performance group. And here we have solutions for asset performance management, reliability, asset lifecycle information management, all of that kind of thing, and analytics as well. And we have a separate business unit now focused specifically on digital cities. How do we stack in the world of other software vendors in this space? Well, the ARC organisation maps part of our revenues under the engineering design tools for plants, infrastructure and BIM, and that covers primarily the capital projects and design side of our business. There we are number 2 overall, and we're number 1 in these 2 industry sectors. In 2019, ARC also said we were number 1 for collaborative BIM in this space as well. On the asset and network performance side for operations and maintenance, our revenues are covered in the asset reliability software report, where we're number 1 overall and number 1 in these industry segments. And we are also recognised by Microsoft on the city side as being their City Next Partner of the Year, an award we've won for a number of years now with Microsoft. Now let me get on to what do we mean by industrial digital twins. Well, a digital twin is the digital representation of physically what is actually happening right now with infrastructure assets. It can be a combination of the CAD model that was created during design, but it also has to be kept totally up to date with what is going on right now. So typically we'll have things like laser scanning and LiDAR added to this model, and it has to be continually updated and synchronized from a number of different sources in order to show what is going on right now. But in addition to that, we feel a digital twin also needs to provide you with insights into what could happen to help organisations make better decisions regarding what their physical asset can do, or can do and should do. So digital twin has to provide insights and generate insights to predict performance and optimize it. So a digital twin comes from a number of different sources. There's the engineering information, the models I talked about before, but also operational information, the real-time information coming from sensors, from IoT feeds, from drones, from cameras, from laser scanning, and so on. And it's also the information about what work is currently going on the assets. So what the tag history or what the tag registry is, what work orders are happening, what maintenance records, and so on. All of this combines into the digital twin of that asset and kept up to date in real time by a number of these things. So at Bentley, we're very much a 3D visual company, as I'm sure many of you know. So the digital twin provides a very 3D visual experience of what's going on, but it also a digital twin needs to show that what's changed over time, the 4D timeline of change, basically, to show what has happened, and then also integrate, as I mentioned before, with things like artificial intelligence and machine learning to enable predictions and be able and provide some indication of what might happen in the future. One of the best descriptions of a digital twin was given by my colleague Bob Mankowski, who gave an interview at this year's ARC forum in Orlando to Jim Fraser. I'm going to now play you a clip of that interview.
Welcome. I'm Jim Fraser, Vice President of Smart Cities and Infrastructure here at ARC Advisory Group. And today I'm very happy to be joined by Bob Mankowski of Bentley Systems. He's their Digital Cities leader. Bob, welcome.
Hey, thank you, Jim.
Digital twin technology today is well known in many areas, but not so well known in the world of public infrastructure. Can you talk a little bit about the impacts of digital twins in public infrastructure and what is a digital twin?
Sure, yeah, no problem, Jim. So let me start there. So what is a digital twin? Well, digital twins as a terminology has been around for quite some time in other industries, but like you said, in the public sector, it's fairly new concept. The idea of a digital twin is to have a virtual representation of like an infrastructure asset, a process such as like the construction process, or systems like water systems, energy systems, transportation systems. So you have a virtual replica of this physical asset that combines the engineering technology, the engineering information you know about these assets, the information technology such as work orders and inspection histories, geospatial information that you know about these assets, and the operational technology such as SCADA and IoT. A digital twin brings all of that information together into sort of a living, breathing, up-to-date representation of the physical world in the digital world. The reason that's important is because you can then use that digital representation to make better informed decisions, ultimately leading to better outcomes such as improved efficiencies, reduced costs, reduced risks, decarbonization, less congestion. There's all sorts of problems that cities face today that they want to find innovative solutions for, and a digital twin can help them in that process.
So that was a snippet of the video of the interview that Bob Mankowski gave to Jim Fraser earlier on this year. If you want to see the full interview, you can see this on ARC's YouTube channel. So my first example of a digital twin being used in real life is the city of Helsinki in Finland. Helsinki won the City's Visionary Award in the last TechFest competition, and more importantly, they won the overall award across all categories. Helsinki have created an entirely up-to-date digital twin of their entire city using primarily LiDAR and reality modeling across the city, but combining that with a number of other sources like the footprints of their buildings and pulling in information from things like radiation, as you can see here playing in the video. They're able to use this digital twin model to plan new areas of construction in their city, to monitor what's actually going on. They actually encourage their residents to provide feedback on what they see via a mobile app, as you see here. And they're also using the digital twin of their city to monitor and predict what will happen should the rivers and surrounding coastal areas flood, and plan for that eventuality as well. The judges in the TechFest competition said the vision of Helsinki to create the most digital city demonstrated the best example of a vision of a digital city of the future. It's built on open sharing and connecting of data, and also gives the potential for city planning and improving the day-to-day lives of the community of Helsinki. My next example is Porto in Portugal. Porto in Portugal are using the digital city to monitor and manage their water supply around the city. The first phase of this project included creating a digital model of all of the assets that they have, combining the reality model of their city and mapping where all of the pipelines were within those cities that provide water supply across the city, and then integrating that mapping with all of the other data sources. The second phase of their project included implementing over 27,000 telemetry points and over 200 devices in order to track in real time what was actually happening with water flow around their city. Additionally, the duration of they were able to monitor the duration of pipe bursts and improve repairs. Now they have integrated their digital city model and their water model with what's going on with the weather and what's going on with coastal tides and what have you, in order to improve decision making and figure out even more opportunities to improve what's going on. Overall, the digital twin of their water infrastructure has improved their overall operational efficiency by 25%, and they've reduced the water supply failures by 30%. The next example I have is the city of Shenzhen in China, in China's Sichuan province. Here they have a lot of congestion, and they needed to overall upgrade this major arterial road going through the city. They combined the engineering information, the models of the new road that they need to build, together with the actual reality model of the city themselves, to come up with the best design for this new road, which you can see is extremely complex. It's a multi-level road. There's underground pedestrian walkways. There's a whole raft of other technologies. They planned everything from how this road was going to be built, how it was going to operate, and as you can see here, all of the different parts of this model: the underground utilities, the underground workflows, as well as the double-decker road itself. This digital twin model of the new road construction scheme in this city improved the overall project team efficiency by 20% and significantly reduced the construction time, including savings in terms of producing the construction drawings, as well as decreasing the overall project cost by around 15%. And as you can imagine, having the scheme also available for all of the city stakeholders to look at as well was invaluable. And in terms of integrating integrating digital twins with construction, this is a kind of a typical example where you have the CAD model of what is actually going to be built, integrated with the schedule of how it's going to be built. And here you have a digital twin of what is going to happen and the way it's been used to plan how construction is going to occur, where the crane movement is likely to happen, and so on. This is a tool called Synchro, and this is a very typical example of the use of a digital twin during construction. A slightly less typical example is here in Pennsylvania at the Shell Chemical project. They fly a drone on a bi-weekly basis to capture the as-is condition of the construction site, which is changing regularly. Here they integrated that reality model, a 3D reality model, with water simulation flood simulation to predict what would happen if there was a catastrophic failure or catastrophic flood from the adjacent Ohio River. They have now been using the combination of reality modelling with with water simulation to be able to better predict where ponding is going to occur as the construction site is changing daily, where ponding is going to occur if there's a heavy rainstorm, and be able to change around what they're going to construct and where they're going to do things based on the weather. An example now in operations and maintenance is the work we're doing with Siemens at this transformer facility in Germany. Here, a digital twin of the entire facility has been captured using a combination of drone photography and upfront close photography. Siemens are the operations and maintenance supplier for this facility, and they have integrated the digital twin reality model with the systems that they use to support maintenance and inspections for this facility. The operators or the engineers associated with this site have access to all of the information from the reality model from the digital twin of this asset, and they're able to remotely look at what needs to be done and send out instructions regarding the work that needs to happen. Integrated into the reality modelling is all of the data, the real-time operating information, the manuals needed to support the facility. And as you can see, they can zoom right up close to the information and really look at what might be going on in order to make decisions about how best to solve any issues. Another example here is the electric and gas utility company of Huntsville in Alabama. Here they have created a digital twin of their assets by combining GIS data and asset information with the map of the city itself. And they have integrated all of the information coming in from the operations systems so that they can check and visually see where outages are occurring, basically, where there's failures happening. So they're combining information that's coming in from the customers and outages together with real-time information from their network regarding where there are issues, and they're able to show on this kind of heat map where the key issues are. In red is where there's all those outages, and they can check to see what might be causing these issues and send a crew out to check what's going on. Another thing that they're using, they have all of their assets mapped right down to the individual houses on their networks. And here they've used this information to figure out where they have voltage issues and check to see what might be going on, basically. So they have an overall map of the facility here, and they're able to zoom in and see where there might be issues regarding what might be causing these issues, basically. And here you can see that there's a transformer with under voltage, and you can see here exactly how many houses that transformer services. They're using this to identify where they might need additional electricity supply, and in this case looking actually at whether it's possible or what will happen if there's a solar panel placed on the roof of this particular house. And they're very easily they're getting a lot of requests from residents for adding solar panels to houses. And you can see here if this house added a solar panel, it would get rid of the voltage issues that they actually have in this particular neighbourhood. And they've been able to use this digital twin and of what they've got here to significantly speed up the time it takes to give permission for residents to add such solar panels to their houses. So where does information from the digital twin come from to pull this information together? And it's actually a lot easier than people think. And this little video will show you an example of how a digital twin has been created from a number of different sources. First, you've got the aerial LiDAR imagery that could have been come from a plane, and then this mapping of the footprints of the footprints of buildings on a GIS system. Then perhaps reality meshes from a close-up from a drone of a particular area, and then the CAD model of a new development. All of this added together comprises the digital twin of this particular area, and it's very, very easy to pull this information together and have this information easily viewable via Portal environments in the cloud, for example. And it doesn't just stop there at outdoor LiDAR type of situations. Here we have used photogrammetry and photography to detail a very complex or very congested plant room for a company in Cambridge in the UK. And this model has actually also been used to test and try the machine learning software we've got to automatically recognise features in a model such as this, which is actually quite complex and quite congested. And the pattern recognition feature or facility can really identify all sorts of objects, even in such a complex model as this. It's a very, very robust detector. And then once you've identified the features, you can then link this up with other real-time sources of information. You saw back then a QR code, for example, or it can read serial numbers, or even tags if you've got tags hanging on the devices. If you want to hear a little bit more about digital twins used for industry in this kind of context, the process and dispute industries, I encourage you to listen to my colleague Amit speaking tomorrow at 11 o'clock, and he'll go into much more detail about digital twins for industry and what is going on there and being used today to improve operational excellence. So thank you very much for listening. Before I go, I'm just going to give a plug to our conference coming up next month in October, where we will have a number of presentations, not only from Bentley themselves, but from a number of our users who are really at the forefront of using digital twins in their environments. We run a competition every year where we ask our users to submit their best projects using the most innovative technologies. We had this year 412 nominations, a good number from India, thank you. And all of these, they've now been judged, and there will be presentations by the finalists leading up to our conference in October, with the award ceremony being on the 21st of October. You'll get an opportunity to view all of these finalist presentations, and a good number of them are using digital twins today, from after the 5th of October onwards to the 21st of October. I do hope you'll be able to listen in and tune in to see some of these presentations. And finally, if you have
So that was an excellent video shared by Anne-Marie. It appears that she's online despite the very late night. Hello, Anne.
Hi there, Raman. How are you doing? Can you hear me okay?
Yeah, it's fine.
Good.
It's nearly 1 o'clock, right? It must be 1:30. Yeah,
it's
great video.
1:30. It's the morning for me and you.
Yeah. Okay. Thanks for joining. This gives me, since we have a few minutes, I'll have some couple of questions to ask you. What do you feel are the main challenges faced by cities and companies in creating digital twins for their assets and using them? See, the question is, what are the challenges faced by the people when creating the digital twins for the assets and then also using them? Because we have been talking quite a lot on digital twins. Your presentation covered quite a lot. So how do you feel the experience now?
Okay, I think what we're finding is one of I think the single biggest challenge with people creating and using digital twins is the quality of the data that they get, that they've got. For sure, certainly the reality modeling and the photogrammetry can capture what is actually there, and then when they are trying to hook that up with there's just so many sensors out there, there's so much data out there, it's very hard for companies and cities to really figure out what is the day-to-day data that they can use and trust all of the time. But one of the advantages, I think, of having the sort of now, especially with cloud technology and being able to put into the hands of the people who are out there using the data, I showed with the Helsinki video that the city, they have the residents of the city with, being able to input into their mobile phones and things like that, information about the potholes and the issues that they're seeing, so that they're able to capture that information, what is really going on out there, and make better use of it. I think, and that scales across all other industries. You have this ability to have these handheld devices connected very quickly through the cloud back to your central systems. You can go beyond kind of marking up paper and getting all of that maybe weeks, months later. A digital twin gives you a real-time view of what you've got, and a real-time ability to update that information. So we're finding people get going with the digital twin, and then they find ways of getting their workers, getting their city dwellers, whoever it is, to constantly give you good information as the digital twin evolves, basically. And as I said, another very critical thing is to show how that is evolving over time as well, so you know where the data's come from. I hope that answers the question.
Thank you, Anne. One more follow-up questions on this is how is the current pandemic helping? How is Bentley helping the people in terms of working remotely? And then I know you are working remote, okay, and sharing your experience with that. How does the Bentley as an organization helping clients to work under these conditions?
Well, that's an also interesting question. We've seen over the past few months, particularly those organizations that were already pretty well on top of their data, and they had, especially in the operations and maintenance context, where they'd really managed their information, and then they knew what assets they've got, and they're managing that information. They've been able to move into having people working remotely very, very seamlessly. Especially, I mean, the big oil and gas companies are classic companies there. We've moved from doing things more face to face to everything being remotely supporting them, basically. And again, those organizations that have got really made major use of the cloud and having everybody connected, even before they were whilst they were in offices, they've been able to move into going from supporting a couple of offices to going to supporting sort of thousands of offices. But those ones who have already got their data under control and are already well connected, especially again leveraging cloud technologies, they've been able to move very, very easily into working remotely, and we've hardly seen a dip in their usage and stuff like that. And we're using webcams all the time. We're doing a lot of in order to support our users. We're doing a lot of remote support, leveraging all of the sorts of technologies that we've got at our fingertips, basically, to support people. Yeah.
Thank you, Anne, for supporting us as a platinum sponsor, and great to have you despite the early morning for you. And then we'll let you go and then catch up some sleep for the day.